Alright, so I recently got the hold of this Eneloop Pros from a local reseller here in the Philippines. And before using this, out of curiosity, I just want to test if it's the real deal. So I got this for around $30. You see, I have 8 of them. And looking at this, looks good. It says here it's made in, hope you can see that, made in Japan. I'm using my cell phone camera. So anyway, this is just a short video. So it says made in Japan and manufactured 2017. See. Okay. So it claims to have a capacity of at least 2,500. Minimum is around, let me focus on that. Hope this will focus. Around 2,400 milliampere hour. So I would like to verify if this is the real deal, because $30 is a lot of money here in the Philippines. So yeah, I just want to know if I get my money's worth. So I'm gonna be opening this one, and to verify the capacity, I'm gonna be using this IMAX B6 charger discharger. So I've already set the discharger here to have for a nickel metal hydride battery for around 300 milliamps discharge rate, and cut-off voltage of around 900 millivolts. So I did some reading, and I think that's these values are safe, at least for this battery. So I'm gonna be using a battery pack. At least I'll just test one, and then so it says here that after a year this should retain a charge of around 85%. So it's been, if it's manufactured just May of 2017, is less than a year. So I'm expecting around maybe to at least 2,000 milliampere hours from this battery. So I'm gonna be setting this up, and then be running, doing the math at a discharge rate of around 300 milliamps. That should take around, if I'm expecting 2,000 milliampere hour capacity, that would take at least maybe 6 hours. So I'll just because I'm holding the camera right here, I'll just set this up, then I'll show you the running status for this one, and then the final results. Okay. Alright, so this is the setup, just a quick setup right here. I pulled just one battery from the pack, and initially I did a voltage reading on the battery, and it's, sorry for that reflection right there, that's 1.3 volts, which is good, because the typical or at rest voltage of this nickel metal hydrides is typically at around 1.2. So 1.3 is good. So it is already set up. See, that's connected to the battery, is connected to the discharger, and then I can start like so, and there you go. Immediately, as you can see, the voltage reading is a bit different on the charger than the meter. It says it says here around 1.28, and then this one is 1.23. So I think it's much safer, assuming this is the more accurate voltage reading, because this is set at 900 millivolts, and the actual voltage may be higher. So Let's see, it's now discharging and it's running. This is the capacity reading right here. Okay, so I'll just show you the final results when it's done. Okay, so here's the result for the first battery. So here are the figures. So it ran for around 4 hours at a discharge rate of 300 milliamps and a cutoff voltage of around 900 millivolts. So the registered capacity right here is 1233, which is I'm not very satisfied with that. And assuming it claims that it has 85% of charge retention after a year, well, this is only around 50% of the advertised 2400 milliampere hour capacity, but that's out of the box charge, so I haven't really used this or charged this. And let's just verify the current voltage of this battery right here. So I'll just connect this to the meter. If I can just, sorry, I'm still holding the camera right here, so this will do. And let's check the voltage. So that's 1.189 volts. Maybe it changed over time, since I just didn't really pay much attention on when this actually ended. So that's it. So I want to do a second test, but this time around I'm going to change the cutoff voltage to 0.8 volts and the discharge current to around 200 milliamps. So to give this battery maybe a chance to maybe discharge longer, because the lower discharge current and the lower cutoff voltage should add additional capacity for this one. So I'll just set this up. Let me just set this up. So I'm only using one hand for this. So we just pull out this one. Okay, and then I'll put a new one right here, like so. So this is a new battery right here, and if you read the current voltage for that one, okay, so that's 1.3. So let's just set the current to 0.2, and then the cutoff voltage to around 0.8, because as we saw earlier, there's a big there's a difference between the current reading and the reading from the meter. So just take my chances and discharge this to around 0.8. Hopefully there will be no damage to the battery, but here goes. Let's just run this again. Okay, so here goes. I hope I can get a better reading on this one, and I'll recharge the first one using the specified race for charging. And okay, let's just wait for the results. So here's the result for the second run of this test. It's pretty much the same, even though I changed the discharge current and the cutoff voltage. So at least these batteries are looking consistent. It's like they have a similar amount of factory charge, I would say. So I will charge those batteries, and then maybe we'll do this again if to see if the capacity reading will improve. Right, so this is the status of the last battery I charged with this same discharger. So the current capacity indicated here is 2476, which is above the typical value for this battery, which is right there, 2450 milliampere hour. And voltage is I'm using my multimeter to really verify the voltage of the battery right here. The voltage is settling at around 1.475, although I read from Eneloop 101 that you can charge this battery up to 1.6 volts maximum, but I didn't really want to go that far. Might damage the battery, and the battery right now is it feels normal, no heating whatsoever. And right now what I'm gonna do next is again perform a discharge on this discharge test on this battery to see if it can hold really that charge capacity right there. So I'll stop now right here, and on the next video I'll give also a brief summary of how this charger behaves, because I didn't really program this, and I read the manual, and I might be able to program this in a way to charge this battery correctly without really damaging it. So I just maybe monitor this for the last 30 minutes because I'm worried that this might continue charging this battery and might cause some damage. So yeah, for the last shot I'll do a summary and conclusion whether I have the real deal or not, since this charging and discharging process takes time. So alright, see you on the next shot. So finally, after 2 days of testing, I finally have the results for this one. Just don't mind the figures for this one. This is the final discharge battery, and I have the final figures. So what happened was, this charger is programmed to cut off at around 420 minutes, which is 7 hours. And I didn't expect that discharging at the rate this battery will be more than 7 hours. So it cut off at around after 7 hours, and then I just continued it. So the remaining charge was 287, and I'll post the during the time it stopped. I just snapped a picture, make another video segment. So I just snapped the picture of the reading, and it's around 2386 milliampere at that time. And just add this one, and that's 2386 milliampere, which is within the, I think so, within the range of the rated capacity for this one. So this is the summary of what we did here. So for battery 1, out of the box discharge test, we have 1233 milliampere hours. For battery 2, out of the box test, that's 1259 milliampere hour. And for the battery 1, after that we charge battery 1, which is up to 2492 milliampere hours. And then this one again, we discharged it, and then we got 2386 milliampere hour, which is close enough considering we have losses and all. And no, it's just a simple setup, no, not controlled environment, temperature and all. So to conclude, I think I got a good deal for these batteries. I think I got the real ones, and there you go. So I'll be charging these batteries using this intelligent charger, this across technology BC 700, I think. Yeah, that's BC 700. So I'll be using this to charge these batteries, and I hope to make good use of them. Hope you learned something. And then for me, at least now, I'm sure that the seller has provided me with a good product, and I got my investment. Okay, so bye, thank you.